Here's another numeration system, the tally numeration system. This might be the system you use when you play board games or dice games with your friends, right? We just use tallies, and every time we reach 5, we draw a tally across. The Egyptian numeration system has their own set of symbols that represent powers of 10. So you can see on your screen, I'm not going to read all these to you, but you want to have this table in front of you when you're working the homework problems over this. Let's try using the Egyptian numeration system to represent the number 2,345,123. So we're just going to look at our pictures, and for example, to get 2 million, I'm going to need to draw 2 of these astonished men, right? So I'm going to draw 2 astonished men. And then I need to do 300,000. My 100,000 is the pollywog, so I need 3 of those. Excuse my artistic ability here. And 40,000, that's going to be 4 pointing fingers. $5,000 is the lotus flower, so I need 5 of those. Okay. Where are we at? 100, so only 1 scroll. 20 is the heel bone, so 2 heel bones, and then 3 units, so 3 lines. All right, and so there we have 2,345,123. And it's not too bad to go backwards from this either. You just look at the symbols in your table and write the numbers that they represent. All right, here's a better picture of that. How about the Babylonians? The Babylonians had symbols for 2 numbers. They had a symbol for 1. It looks like an upside down colored in triangle, and a little Pac-Man for 10. They used a place value system like we use powers of 10, except now their powers are going to be powers of 60. Okay, so here I have 2 Pac-Mans and then 3 upside down triangles. The 2 Pac-Mans each represent 10, so this gives me 20, and then I have 3 here, so 20 plus 3 gives me 23. Now, if I want to represent numbers bigger than 59, I'm going to use a little space to help illustrate that I've moved place values. So here, I want to think of this, the place here as my 1s, and then this place is going to be my 60s to the first. And if I were to have a space here and another one, I'd have 60s squared, and so on. So this is telling me that I have 2 60s, and then 10 and 10, or 2 times 10, 1s. And so I add those together to get 140. So this picture represents 140 using the Babylonian notation. All right, the space is what's telling us that this is the 60s place over here on the left, and not part of combining those 2 Pac-Men and those 2 units as one number. Okay, so that space is going to be really important. Let's look at another example. I want to use the Babylonian system now to go the other way. So I've got a number, 305,470, and I want to represent it using Babylonian notation. Well, since the Babylonian notation uses powers of 60, off to the side I'm going to do some work to calculate powers of 60. You might want to pull out a calculator to help you as we go through this. Whoops. Sorry. Okay, so 60 cubed, that's a terrible 3. 60 cubed is 216,000. 60 squared is 3,600. Obviously 60 to the first is 60. If I go to 60 to the fourth, I'm going to get something bigger than 305,000. So I only need to go up to 60 cubed. Now what I want to think about is I need some number of 60 cubes plus some number of 60 squareds plus some number of 60 to the first plus some number of ones. And that's going to help me figure out my Babylonian notation. So the first thing I want to do is take 305,470 and ask how many times does 60 cubed, or 216,000, go into that? Well, that's only going to go in one time. Okay, so 305,470, I'm going to do some scratch work down below, I guess. 305,470 minus 60 cubed is going to leave me with 89,470. And I took 160 cubed, so I'm going to represent 1 with the upside down triangle. All right, now I want to know, I've got 89,470 left. How many times does 60 squared go into that? So you could pull out your calculator and divide 89,470 by 60 squared. And what you'll get is 24.8 something. What that means is that I can multiply 3,600 by 24 and still remain below 89,470. If I were to multiply by anything bigger than 24, I'm going to be above 89,470. So I want 24 60 squareds here. Okay, to represent 24, I'm going to have 2 tens, so 2 Pac-Men, and then 4 units, so 4 upside down triangles. Okay, and again, I want to do some scratch work. 89,470 minus 24 times 60 squared. You should do this on your calculator. I got 3,070. So now we're looking at 3,070, and we want to know how many times does 60 to the first go into 3,070. This one you could do with long division or pull out your calculator, and you should find that 51 times 60 to the first is still less than 3,070. If I do 52 times 60 to the first, I'm greater than 3,070. So I get 51 60s. So 51 is going to be 5 tens, 5, and 1 unit. And now I want to subtract 3,070 minus 50 times 60 to the first. That leaves me with 10. So I'm left with 10, and I want to know how many ones go into 10. Well, 10 ones go into 10. So I need 10 here. That's the Pac-Man. Okay, so this right here is my representation of 305,470 in Babylonian notation. Notice I've got the spaces there to help me distinguish my place value. All right, so that's the Babylonian system. We'll look at some more systems in a minute.